Hello, my name is Valerie Simon, and today I'm going to be explaining how to write the molecular, total, and net ionic equation for two types of reactions. First one would be acid-base reaction, and the next one is going to be a precipitation reaction. So here's an example of what happens when aqueous solutions of hydrochloric acid and sodium hydroxide are mixed. So first of all, the first equation that we're going to write is going to be the molecular. So first we're gonna write hydrochloric acid. So hydrochloric acid is gonna be HCl, which is H plus Cl minus. Okay, so then what is it? Sodium hydroxide. So sodium hydroxide is NaOH, so that's gonna be Na plus OH minus hydroxide. NaH. Okay. So then we already know our acid that's gonna be HCl, and then our base that's gonna be sodium hydroxide. So then for the molecular equation, we're gonna list all reactants that will be HCl and OH, and then the products and the state in their states. So HCl, they already told us the states, that will be aqueous, so HCl aqueous plus NaOH aqueous as well. Now we're gonna write the product side, and the way we do it is that we go inside, then outside, and in order to do this you have to separate the ions of HCl and NaOH, but we already did it here. So it's gonna be this one with this one, and then this one with this one. So it's gonna be NaCl plus HOH. So it's gonna be water. So we already know the stage of water is liquid, and the stage for NaCl, you gotta go on your solubility table and check. So here on your cheat sheet says that Na is generally soluble and there's no common exception, so this is gonna be aqueous. It has a strong solubility, therefore it's gonna disassociate into its ions. So that would be aqueous. So it's HCl, NaOH, NaCl are strong, so they're gonna disassociate, while water is gonna stay together since it's weak. So where is it? So now you gotta keep that in mind for the total equation. That will be this one, since you gotta list all the ions present in the solution. So and you also have to include the ones that are that don't disassociate, so that will be water. But yeah, you gotta know the stages in order to do this part. So since HCl, NaOH, and NaCl are strong, we're gonna list all the ions. So it's gonna be H plus in their stages. So aqueous plus Cl minus aqueous. So then plus Na plus aqueous plus OH minus aqueous. So then it's gonna be Na plus aqueous plus Cl minus aqueous plus H2O. This one does not disassociate, so liquid. So then we're gonna calculate the net ionic equation. So you're gonna list all species like in the reaction, but you're gonna like remove the spectator ions, and the spectator ions are the ones that like do not, how do you say this, like they do not change. They're like the same in the product and reactant side, so they subtract each other, so, and they should be removed, like since they do not change. So we're gonna remove CO and we're gonna end up with H plus aqueous plus hydroxide aqueous H2O. There, I think I did it right. HCl. Yeah. So keep in mind that it's really important to know like the states, because that's gonna play a huge role on the total and net equation. And also molecular, like pretty much you really need to know your solubility rules and like have your like table and know how to like work with it. So that would be for an acid-base reaction. So now for precipitation, I mean, it's pretty much the same process. You also have to know like your solubility rules. But okay, we're gonna work on it. So it says, what happens when aqueous solutions of barium nitrate and potassium sulfate are mixed? So first what we do is that we're gonna like write barium nitrate. And that's gonna be barium and then nitrate is NO3 minus. Yeah, NO3 minus, so then okay. So that's gonna be 2 plus NO3 minus. Yeah, barium nitrate, and then potassium sulfate. So potassium is K, sulfate is SO4, 2 minus. So then 2SO4. Hold on. K plus CO4, 2 minus. Okay, yeah, it's like that. So then here are your like barium nitrate and potassium sulfate like separated in ions already. Oh, what did I do? Okay, so then we're gonna start with molecular. So we're gonna like list all reactants and then like also the products and this like their states. So barium nitrate, NO3, they already said that it's aqueous, plus potassium sulfate, that's going to be K2SO4, also aqueous, right? Yeah. So then the products, we're going to do the inside, outside. So, boop, this one and this one. So this with this. So that's gonna be SO4. SO4, right? Okay. Oh yeah, because you can tell now. And then it's gonna be KNO3. Yeah. So then now you go on your solubility table, and look for barium. So barium, where is it? Barium 2 plus and sulfate is I can't read. Okay. It's not, it says it's insoluble. Insoluble. So that means it's solid. I mean, and also like weak. So then for KNO3, everyone, so all K's are soluble, so it's gonna be aqueous. So we have 3 aqueous, so 3 strong, so they're gonna like dissociate into its ions, right? Yeah, so they're gonna dissociate into its ions. Okay, so now that we have listed like all the products and all the reactants and their products and their states, we already know that also this one is strong. So all the strongs are gonna dissociate into its ions, and the weaks are gonna like stay together. So this one's gonna stay together when we do the oh my god, what is it? The total equation, the total ionic equation. So we're gonna move on and do the total, and then we're gonna like list all the ions present in the solution, including even like the barium sulfate. So we have our molecular equation, but we also have to make sure it's balanced. So BaNO3 wait, it's not balanced. 22 out of 2. Oh, what did I do? So we need to add a 2 here. 2K. Okay. So now we're gonna do our total ionic equation. So it's gonna be like list all the ions in the solution, even this one, even though it doesn't dissociate, since it's like this is solid. I mean, since it's weak, so it's gonna be Ba2 plus aqueous plus 2NO3 minus aqueous, and then plus 2K K plus aqueous plus, so 4 2 minus aqueous, and then this one's gonna stay the same, and then it's gonna be plus 2K plus aqueous plus 2NO3 minus aqueous. Okay, I think that's right. So we already list like all the ions and their states for the total, but now we have to subtract and like remove the spectator ions, so the ones that do not change in the product or reactant site. So it's gonna be this one. So that's how we're gonna get our net ionic equation. So like the species are actually like driving the reaction is gonna be Ba2 plus aqueous, or SO4 2 minus aqueous, and then EaSO4. So that would be your net ionic equation. So remember, it is essential to know your solubility rules, how to use your solubility table. Also, to know like how to separate the ions and know which one, like what, like, oh my god, how to know, like, you know, how to use your periodic table and know the oxidation stages. And also remember the inside outside rule in order to calculate the products for the molecular equation. And then also know that strong do not, oh my god, the strong dissociate into its ions, and then weak stays together, because it is essential for the total ionic equation. So yeah, I think, I don't know what else to say, but yeah, I think that should be all for this explanation. I hope this actually like explains something. I'm a really bad person, like I'm a really bad at explaining stuff, so I really hope this worked, I guess. Thank you.